Hello and welcome back to Maths with Mr. Duffield. I am the aforementioned Mr. Duffield, and what I've got in front of me is a past paper question on the GCSE paper that I gave to my UF and GE classes last week. A number of questions have come up as being particular humdingers. I'm going to go through them in a bit more detail than just the mark scheme tells you. Question 14. Complete the table of values for y equals x cubed minus 2x squared minus 3x plus 4. So we're substituting each of these x inputs in and writing the corresponding y value underneath. Okay, so first of all, minus 2 substituting in to this equation. Negative 2 cubed makes negative 8. I've already written that down. Minus 2 squared makes positive 4. Multiplied by that negative 2 makes another negative 8. And similarly, dealing with two negatives multiplied together, a positive 6 appears here, and then plus 4 at the end. Those combine to make minus 6. Minus 1, similarly, each little part. Negative 1 is negative 1 cubed. Minus 2 is what comes from the second. Plus 3 and plus 4. This cancels out and leads to just 4. 7, 6, 5, 4. Yep. 1 into that gives you 1. Minus 2, minus 3, plus 4. That actually all cancels out and leaves you with 0. 2. 2 cubed is 8. 2 squared times 2, minus 8 overall. Negative 3 times 2 is minus 6. And then plus 4, that becomes negative 2. And then 3, the numbers are getting a bit bigger now. 3 cubed, is 27. 3 times 3 is 9 times 2 is negative 18. 3 times minus 3 makes minus 9, and then plus 4. And to those of you who are initiated, negative 18, negative 9, they make positive 27, cancels out, and you're just left with 4. So down here is where we're going to plot. We're going to draw the graph of what we've just come up with. Minus 2 along, minus 6 down. There it is. Minus 1 along, and 4 up this time. It's a big old jump. And then minus 0.5 to minus, or positive, 4.875. Just shy of that 5 line here. 0 goes down to 4 again. 1 decreases to 0. 1.5 goes to negative 1.625, roughly about there. 2 decreases to minus 2, and then 3 up to 4 there. Okay, so you can see here that we've got a sort of wave happening, and that's because of this cube sign on the x. Joining these all together, a bit tricky. You're going to have to forgive me, and yeah, I am aware that obviously I'm a little bit out of practice when it comes to drawing this kind of stuff. But we're supposed to be joining these together, hopefully with a nice, smooth line. Trying to represent that kind of slope. Now, I've made a little bit of a mistake on this one. Hopefully that won't have too much of a bearing on what comes next. But as long as you have a nice, smooth line that goes through all the points, you're likely to get all of the marks. Okay, part C, probably where most people are finding difficulty, really. By drawing a suitable straight line on the grid, find estimates for the solutions of the equation x cubed minus 2x squared minus x plus 1 equals 0. Give your solutions correct to 1 decimal place. Okay, so the equation that we've actually drawn is x cubed minus 2x squared minus 3x plus 4. X cubed minus 2x squared minus 3x, plus 4. In essence, that's the graph that we've got, and this is the function that we want to solve. We're going to need to rearrange this by doing things to both sides of this equation until we get back to this function that we've got, because this is the one that we've got a graph for, unfortunately. So let's do it. How do I get my x terms to be minus 3x instead of minus x? I've got to take away 2x from both sides. How do I get from 1 to 4 here? Well, I achieve that by by adding 3 to both sides. Okay, so the final function, the final kind of rearranged form, becomes x cubed minus 2x squared minus 3x, because of that minus x and that minus 2x, plus 4, because of this positive 1 and this plus 3, and then on the other side is going to be minus 2x plus 3. I've effectively rearranged both sides of this until this kind of cubic on the left matches the graph that I've got. Okay? Now, in order for that to happen, that 0 needed to become minus 2x plus 3. So the function y equals minus 2x plus 3 is the suitable straight line on the grid that effectively solves this equation. Because if I've solved this equation, well, I've solved this. Because these two are rearrangements of each other. So they're equivalent to each other. So the values of x that work for this equation are the same as the value of x that works for this equation. Okay? So y equals minus 2x plus 3. Let's put it on this graph. Minus 2x, yeah, just check, plus 3. Okay. Whew. Okay, so minus 2x is the gradient and plus 3 is the y-intercept. So 3 is where it cuts through the graph. And every time I increase my graph by 1, it slopes down by 2. Increase by 1 goes down by 2. Increase by 1 goes down by 2, and so on. So that is the straight line of y equals minus 2x plus 3, and that's what I'm drawing on this graph. Now the mark scheme is probably going to say something like evidence of the line being drawn is required for the full marks for this, because we're looking for where the line that I've drawn on here, the straight line, intersects with the function that I drew in the previous part. And how do I work out the remaining values? I read down from where they intersect to the x-axis, and the resulting x value that I get is the solution. So that will be minus 0.75 about, I guess. Doesn't have to be perfect. Over here, 1, 2, 3, 4, 0.45 probably, thereabouts. And then up from here, there we go. 2.1, 2, 3, 2.32 or something. It's rough. It's approximate. 2 decimal places is probably too far of a guesstimate to be making, really. Anyway, let's take those values as what they are. Just bear in mind, the question does say give my solutions correct to 1 decimal place, so I do have to round these values anyway. Negative 0.75, that will round to negative 0.8. 0.45 here, that'll round to 0.5, and then 2.32, that's going to round to 2.3. Okay. Now that last particular part there is a particular humdinger. It is tricky. I have struggled with it myself, as at least one of you are well aware. But as long as you're able to come up with the y values, plot the points and draw the function, you're 90% of the way there. Part C, when it comes to rearranging, that's almost a different skill entirely, and it does come up on past papers and current papers. So please make sure that you are aware as to how to rearrange a slightly different cubic or whatever function that you're drawing to work out what straight line function you need to add to your drawing in order to find those intersections and those x values. Great. I've started as I need to go on. It's been a fairly intense video, but I hope that it makes sense. I trust that you're getting your work done, and for goodness sake, get your work done on Teams. I will talk to you very soon.